All right, welcome to part 3. In part 3, we are going to be talking about electrons and electron movement, okay? As we are talking about electrons and electron movement, we're going to kind of go back and cover what we covered before and how all these connect. All right, if you remember, one of the first things we did is we started figuring out exactly what the components of an atom were. So the components of an atom, again, you have your nucleus made up of your protons, positively charged, your neutrons, which are no charge, and around your nucleus, you have your electrons. And last lesson, or last lecture, we just started talking about what the atomic number is. It's your number of protons and neutrons. And then we started talking about the periodic table and what role that plays. If you guys remember, the number of protons equal the atomic number. And then by using the atomic number, we can figure out what is the element that we are looking at. So when we continue to look at an atom, we are now going to start talking about what in the world the roles do electrons play, okay? This part right here, you don't have to write down, but it is pretty straightforward where it says, in this unit, we mainly care about electrons in atom. Why? It's important to understand the how and why of the movement in order for us to understand how electricity works. And that's our ultimate goal. Between this big lesson and our future lesson is we're going to be learning about how electricity works. And that is due to this lovely thing called an electron, okay? So one of the things that we want you to do is we want you to write this part down right here. You don't really have to draw the drawings. It's going to make no sense later on. But we want to talk about a valence level, okay? A valence level is something that an atom can have up to 7 orbitals. If you guys remember, and we go back right here, where we're talking about our periodic table, remember how we talked, there were 7 different colors. That means that there are 7 different levels of electrons. So when we draw our circle, I'm going to kind of show you this here, we draw our atom, and we're going to do the 2D model. So I'm going to be drawing it here. We have our protons plus neutrons in the center, and outside of it, there are going to be, as a maximum, and my drawings are lovely, 1, 2, 3, 4, 5, 6, 7. Look at this lovely drawing right here by Mr. Eddie, okay? So those are the number of orbitals, and that's going to play a role with how many electrons can be, kind of circling in that orbital, all right? So as we go through here, I want you to write down this note, valence level and the number of atoms. You do not have to draw any of this. Take notes. That's my 5. I'm holding a cat. All right, so we're back. So this is the part that's going to get tricky, and I'm going to try to explain it to you the best I can. And if I struggle with it or you struggle with it, this would be a great spot for you to email me or let me know that you have questions, okay? So I'm going to kind of play all of this stuff first, and then I'm going to explain it for you, okay? So now would be a good time for you just to kind of write notes. I want you to write everything down here, okay? So that was your take notes. So let's talk about electrons. So electrons, they reside in the electron cloud, and that is the part that is surrounding the nucleus. So when we go back and we have our atom with our proton and our neutron, which are our nucleus, it is the things that are surrounding on the outside of our atom, okay? So right here, you'll start to see kind of the circle that goes around it, and I'm trying to do this backwards. That is the electron cloud. Again, they are divided into 7 energy levels. And electrons, they're kind of lazy. And I always say they're kind of lazy like middle school students and teachers and basically every human that's ever existed. They want to do as little work as possible. Okay, so in order for them not to climb as many stairs, and we're going to use an analogy here in a little bit of an apartment building. That's why there's an apartment building kind of right here. They want to reside in the lowest energy level whenever possible. So for your notes, you should have written all of these 3 things down. Okay, and we're going to move forward so then I can kind of explain. All right, so this part down here, you do not have to draw these drawings. Please don't. It makes no sense. It's just really confusing. So electrons. Areas within each energy level where electrons move around the nucleus of an atom is known as an electron orbital. Okay, so let's go back to our drawing, and I'm going to try to point as good as I can. When it goes around, that's an orbital. If you remember, when we talk about space, an orbital is something that goes around and around and around. A level is the number of circles there are outside of the nucleus. So 1, 2, 3, 4, 5, 6, we get up to 7. Okay. In our case, there are 4 different types of orbitals. So I do want you to write all of this down. Each type can contain a different number of electrons. The only thing that I want you to write down is the letters that each one starts with. There's an S type, there is a P type, there is a D type, and an F type. So on the bottom, when you get done writing all of this, you are just going to write S, P, D, F. Okay? We don't care that it's called a sharp, a principal, a diffuse, and a fundamental. We are just going to use them by the actual initial. All right? So now you're going to take notes. All right, and we're back. So you should have this written down. And again, let's talk about electrons. They reside in the electron cloud. That's the thing that goes around and around the nucleus. There are 7 different levels. Those are the circles around the nucleus. And electrons go in the lowest one. The orbital, again, is that thing that is surrounded, okay, and goes around. So if that little is the nucleus, that just keeps going around and around and around. My drawings are lovely, okay? All right, this slide is going to be a lot of writing, so I'm going to show it to you first, and I want you to write it down. Okay, I want you to write this information, and then I want you to make this chart. And we're actually going to make this chart twice. Okay, we're going to do it this way, and then we're going to do it the way that shows the tower version. Okay, so let me give you time to take notes. Five. All right, so here we see that the s orbital, or shape which we don't really care about, can hold 2 types of electrons. A p type of orbital can hold 6 electrons. The d can hold 10, and the f can hold 14. Okay, so over here we have our 7 different levels. Our remember, we call these our valence levels. There are 7 different possible circles around the nucleus. Okay, each one is made up of a particular oval type. So for number 1, it's just an S. So the maximum number is 2. For the second level, you can have an S-type orbital and a P-type orbital. 2 plus 6 is 8. For 3, we have S plus P plus D. 2 electrons plus 6 electrons plus 10 electrons equals 18 total in the third level. Okay. The fourth level, we have all 4. And when we add those up, we get 32. In the 5th level, we have 32 because we have all 4. The 6th level, it gets smaller. We have S, P, and D, which is back to 18. And in the 7th level, we have just an S and P, which is 8. If we add all up these maximum number of electrons, what number do you think we get? Think back to the video we watched during section 2. 118. You're exactly right. Nice job. And so as we do 118, that's how we're going to break it down. So what in the world does this actually mean? All right, so this is the part I want to show you. This is the part where you're going to redraw this in a different form. Okay, so when we talk about electron levels, we talk about the circles around the the nucleus, and we're talking about, okay, how do electrons kind of move around that? I want you to think of it as an apartment building, okay? So on the first floor, there's 2 rooms, okay? So an electron can fill each room. So in this case, there's 2 electrons, 2 rooms. On the second floor, we have an S type of room and we have a P type of room. An S type of room can hold 2 electrons. A P type of room can hold 6 electrons. So for a total, 8 electrons can live on the second level. Again, on the third, we have an S, a P, and a D. So again, an S is 2 electrons can live in there. A P, 8 electrons, and a D, sorry, 6 electrons. A D is 10 electrons for a total of 18. And it goes all the way up. So let's talk about our apartment analogy. Okay, we already earlier talked about how electrons are kind of like middle schoolers and are kind of just like people in general, where sometimes we're kind of lazy and we want to try to get in the lowest level possible, right? Like if you don't have to walk upstairs, you don't need to walk upstairs. Okay, so what happens is we are going to first fill in the first floor of electrons, and then we're going to fill in the second floor, the third floor, fourth floor, fifth floor, sixth, and seventh. So we're going to keep working our way up. It just works like that because we don't want to make sure that things are jumping all the way up to the top floor. We don't want to spend that energy if we don't have to, if we are the hotel manager. Okay. Sorry about that. Had a cough. All right. So how in the world does this actually work? And how do we actually go in and fill in our circles? And do we determine how many electrons are on an actual atom? Okay. If you remember, and I'm going to draw something here for you, we have an atomic number, and we're going to use the one that we had before, 6 carbon, okay? And I think the number was like 12011. So this should look familiar, okay? That is something you have in your notebook. So we are going to take this and we are going to draw it in a 2-dimensional form. So what I'm going to do is I'm going to draw a circle. That circle is going to be the nucleus. And inside the nucleus, I'm going to put a P and an N. So you guys can follow along with me as I'm doing this. Now we need to identify how many protons and how many neutrons are in this atom. Okay, if the atomic number is 6, how many protons do we have? 6. So I'm going to write 6 in there. So now I have 6p blank n. What's our atomic mass? Our atomic mass here, right here, is 12.011. Let's round it to 12. So in order to find our number of neutrons, we know we need to take our number of protons and subtract it from our atomic mass. So 12 minus 6 gives us 6. You guys are smart. So we have 6 protons and 6 neutrons. The question is, how in the world can we figure out the number of electrons in the atom? If you guys remember from the video, it mentioned that the same number of protons, there's the same number of electrons. And that goes back to our magnets where we talk about how opposites attract. A positive charge and a negative charge will then match up, okay? So in this case, we have 6 electrons that we need to go in. Sorry. Where is that? There we go. I'm working on this. Not perfect, but we'll get there. So we have 6 electrons that need to go on. So what I'm going to do is I'm going to draw my first orbital. My first orbital is this down here. How many electrons can fill in our first level of our hotel? You guys are right, 2. So I'm going to make my circle a little bit better. Okay. So I'm going to draw my circle around it, and I'm going to put in 2 electrons, one on top, one on bottom. So now I have a nucleus, and I have my first orbital level, which can hold 2 electrons. I'll be honest, some of you are questioning, well, why is that? That is beyond what we are going to do in 7th and 8th grade science. It just is what it is. So certain times during this year, Mr. Wall and myself, we're just going to say, it is that reason. You don't need to know it. It's just going to confuse us more. This is one of them. It is what it is. So if we take 6 minus the 2, we are left with 4 electrons. Let's look at our second level. What is the maximum number that can be in our second level is 8. So let's draw our second level. We can put 1 on, 2 on, 3 on, 4. So we add 4 more. This is now the drawing we have for our element. We have 6 protons, 6 neutrons, and 6 electrons. So you should have something drawn in that. The other question I want to ask is, how many orbital levels do we have? So you're going to look at that and you're going to count. I see 1, 2, 2 orbitals. All right, so we have 2 orbitals. So I'm going to come back here and I'm going to show you 1, 2 orbitals. The other question that eventually we're going to talk about is this thing called valence electrons. And valence electrons are those electrons that are on the outermost orbital, okay? If you remember, and I'm going to scroll back through here, and I apologize, this is going to take a second. When we got to our periodic table, remember how there were 8 groups here? This tells us the number of valence electrons. And what a valence electron is the outermost electrons on an orbital. So 1, 2, 3, 4, 5, 6, 7, 8. So in our case, there can only be 8 on the outermost at any one time. Again, confusing, but that's all you have to know. The number of valence electrons, the max is 8. Okay, the number of orbitals, 7. So 8, 7. So let's go through here. If we have 4 on the outermost, because right now we have 4. Let's count the outermost. And I'm really struggling with this. 1, 2, 3. By the way, my camera's backwards. That's why it's funny. 4. So there are 4 valence electrons. So if we were to fill this out, we would find that we're 1 red, 2, 3, 4. So somewhere in here is going to be my element. Okay? If we have 2 orbitals, let's go. 1, 2. So I'm in the second row. Okay? Second row, 4th one over. So right here is my element. And let's count using our atomic number. 1, 2, 3, 4, 5, 6. 6 should be right here, which should be carbon. And if we go back to our periodic table a little earlier, let's get there. Right here, number 6, look at that. It's carbon. So that's how we can kind of combine all of these, okay? So we have this going on with our tower. Question is, what happens if we get a bigger number, okay? What I'm going to do is on the next slide, there is a video that you guys are going to watch, okay? Actually, hold on here. This is something that I want you to see. It's going to be important because this is going to be the video that you talk about. So I do want you to write this into your notes, okay? By the way, if you have not, pause and take notes on this. So you should have drawn this in, and I want you to draw the little tower, okay? On your next, down below, I do want you to write kind of this whole example in, and it's going to get confusing, but I will walk you through what it looks like. So electrons, they will not completely fill in all the orbital in an energy level before moving up in order to fill down. Very confusing. You don't have to know exactly why that is. It has to do with the shape and things like this. But what I want you to do is don't necessarily draw these arrows in, but I want you to kind of draw 1, 2, 3S, 4S, 5S, 6S, 7S. Draw this triangle-ish type chart in. Okay, so I'm going to give you time to fill this out, and I'm going to have you take notes. All right, so you paused the video, you went to your document that you're holding up as well for your atomic structure, and you filled this out. What in the world is this? Let's watch the video, and then we are going to practice together. This guy does it on a number that's 32. That's higher than anything we're going to do. If you want to practice on a higher number, you can. But the reason why we care is we need to know the number of orbitals. So in this case, when we get to germanium, he has 4 orbitals, and we need to know the number of electrons that are on the outermost level. So I'm going to sit back. I'm going to let you guys watch the video, and then I'm going to kind of explain, and we're going to work through a couple of problems together, okay?
Honestly, I've never seen a question that asked a student to draw a Bohr-Rutherford diagram for an element beyond number 20, which is calcium. The reason is that it gets kind of complicated as you progress through the periodic table. I'm going to show you here how you could do it, just in case someone gets asked, or if you're just curious. We're going to do it for number 32, which is germanium. Now, you always start Bohr-Rutherford diagrams the same way, with the number of protons in the center and the number of neutrons in the center. I'm going to assume that this is about 73, or we'll use the isotope that has an atomic mass of 73, which means we have 41 neutrons. All right, take a look at what I have here. This is a little chart where you have the S's down 1, 2, 3, 4, 5, 6, P's starting at 2, D's starting at 3, and all the 1s and 2s and 3s and 4s are aligned. This chart is going to tell us how many electrons to put in each shell as we progress through. What we're actually going to do is start in the lowest level electron orbital, the 1s, and put in 2 electrons. So we draw our first shell, we put 2 electrons in that first orbital. The S here stands for the shape, which is spherical, of the orbital, but the important thing is that all the s orbitals can only handle 2 electrons. So we put 2 electrons in the first shell. Then we put 2 in the second shell. 1, 2. Then we put 6 in the second shell. 1, 2, 3, 4, 5, 6. What I'm doing is progressively drawing diagonal lines through my chart, and it's going to tell us the order in which we put electrons into the atom. So 2 into the first, 2 into the second, 6 into the second, 2 into the third. So I need another line here. 1, 2. Now I need to add another 6 to my third. 1, 2, 3, 4, 5, 6. And I need to add my next 2 to the fourth shell. Now I've written 20 electrons so far. And in most of high school, when you're drawing Bohr-Rutherford diagrams, this is as far as you would go. And the reason is that the next shell you put electrons into, line, 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 is now you can put up to 10 back in the third shell. 2 electrons go into the fourth shell before you can put any into the third shell. It's a little weird, eh? But according to the order of filling that I have down here, that's the way it is. So I'm putting 10 in my third shell now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Almost ran out of space. So I have 30 electrons now, if you've been counting, and I only need 2 more. They happen to go in the fourth shell. 1, 2. Now I spread them out because P's can handle 6, and so those 2 electrons aren't automatically paired. All right, 32 electrons, 32 protons, and 41 neutrons. The trick with elements that have an atomic number greater than 20 is that you have to follow this order of filling and put 2 in the first, 2 in the second, 6 more in the second, 2 in the third, 6 more in the third, 2 in the fourth, and then come back down to the third shell. Put 10 in there. Then 6 more in the fourth, then 2 into the fifth before you go back to your fourth shell and add some there. It gets really complicated, but this is the way that we fill electron orbitals with atoms, from the lowest energy up. Best of luck.
All right, so confusing, but what we're going to do is we are going to practice our own, okay? So I'm going to kind of leave that video up here. We're not going to play it again, but what I have right here is I have atomic number 18, which is argon. We have our atomic number. We have our atomic mass. So now let's go in and let's fill this in. And I want you guys to do this in your notebook as well. So again, our atomic number tells us the number of protons, which in this case is 18. We have an atomic mass of 40. Sorry. In this case, what's 40 minus 18? It should give us the number of neutrons, which is 22. So far, so good. Okay. All right. So let's draw some orbitals. We're going to draw our first orbital, and we are going to fill in the chart over here. So 1s, we can fill in an s orbital. Takes how many electrons? You guys are right. 2. We cross it out. So there we go. Our second orbital is also an s. So we're going to cross that out. So now we're in our second orbital. We're going to put in 2 more electrons. 1, 2. We're going to put them as buddy-buddy. They're going to be right next to each other. Now we are going to go in and we are going to fill out a 2p. So we're in the second orbital. We're in the p type. If you remember from your chart, that means 6 more electrons. 1, 2, 3, 4, 5, 6. So that's a total of 8 electrons on that second level. If we add the 2 electrons from the middle level, we're at 10. How many does that leave us? 8. So let's draw our third level. So now what we're going to do is we're going to keep going diagonally. We started here. We are now going to come over to 3s. We're going to cross that out, and we're going to add 2 more electrons. 1, 2. They're going to be buddy-buddy. So now we're at 12. What's our next one? 3p. 3p, remember p orbitals can hold 6. 1, 2, 3, 4, 5, 6. So let's count the number of electrons. 2 in the first orbital, 2 in the first orbital, 8 in the second orbital, and 8 in the third orbital for a grand total of 18 electrons. Remember, 18 electrons, 18 protons. So now is the next step. We need to figure out what is the number of orbitals and how many valence electrons in the outermost level. So let's go through. Let's count our orbitals. 1, 2, 3. So I'm going to write that down. 3 orbitals. And I'm going to count the maximum number. If you remember from our periodic table, what is the maximum number on the outermost? It should be 8. So let's see if we have 8 or less. 1, 2, 3, 4, 6, 7, 8. 8, and I'm just going to put VE. VE stands for valence electrons. That information right there is going to tell us some important information here in a little bit. All right, we're going to practice one more. Okay, and what I would like you guys to do is I'd like you to pick one somewhere between 5 and 20. Okay, so let's say you end up picking, not 6. You can't do 6 or 18. Let's say you do 13. Okay, periodic table, I want you to go and find what 13 is. Okay, for me, I'm just going to say that the atomic number is 26. It's not 26, but I'm making my life easier. Okay, so I'm going to count the number of protons. There are 13 protons, and in this case, there are 13 neutrons. Again, I know the atomic mass is not correct for 13. I just don't want to waste any more time. I'm going to fill out the little triangle thing that he has. 1s, 2s, 2p, or 3s, 3p, 3d, 4s, 4p, 4d, and 4f. If you guys remember, this is identical to the tower that you built that looks like this, okay? The same exact thing, okay? So let's go through and let's fill it out. First orbital, 1s can hold how many electrons? You're right, 1, 2. Second orbital, we start with 2s, 1, 2. Then we go to 2p. That's 8, 1 or 6, 2, 3, 4, 5, 6. So we've had 10. We're going to go one more orbital, our third. So our first third is the S. 1, 2. That's 12. And we have 3p. We have one left over. So now we have 13 neutrons, 13 protons, 13 electrons, and we made up 13 neutrons. Let's count the number of orbitals. 3 orbitals. How is the number of valence electrons? The outermost. 1, 2, 3. So there's my answer. That's what we should be able to do. All right. So by the end of this lesson, that's what you're going to do. Okay. So what in the world does this have to do with, pause, take notes. And by take notes, I mean go and fill out in your notebook. All right, so what does this have to do with electricity? Okay, one thing we know is that our electron orbits is that atoms work to have their valence level. The valence level is the outermost level. They want it either filled or empty. And the reason why we talk about this is when we go back to the conversation of, excuse me, the apartment building. If you have one person living in an entire apartment floor, you've got to turn on the water, you've got to turn on the lights, you're wasting a ton of electricity. So if it's better to either have that floor completely full of people or completely empty. And that's the same exact way that this outermost level wants to be. It either wants a full number of electrons or it wants very few electrons, 0 electrons. Okay? So in this case, we have 1 electron. So would it be easier to get rid of the electron or to try to gain more electrons in order to get to either 0 or 8? That is what we're trying to do. We're trying to get to 0 or 8. Okay? So I'm going to pause and let you write this information down. You don't have to draw this right here, but we'll talk about it. So pause, take notes. All right, I'm going to ask that same question I just asked. Is it easier to get rid of 1 electron, or if we're trying to fill it up to 8, or gain 7? Right, it's easier to lose 1 electron. So this electron has a really loose hold, is what we call it, on this atom, meaning that this one is kind of available in order to kind of move to other electrons. And guys, that's electricity, is when electrons move from one atom to another atom. Okay, so if we move on the next slide, you're going to see that in case there's 1, it has a loose hold, and so it can be easily moved. So what does that look like? Okay, here is sulfur. Sulfur, let's count the number of valence electrons in the outermost level. 1, 2, 3, 4, 5, 6. So there's 6. Is it going to be easier for this atom to gain 2 electrons to get to 8 or lose 6? It's going to be easier for it to gain 2 electrons in its outer level. And like we said, an apartment floor wants to either be completely full or completely empty. Okay? So that's what electrons are trying to do. So how does this, or what does this have to do with electricity? Okay? I'm going to take a second and I'm going to let you write this information down. Okay? So take notes. So here we go. The valence electrons, that number on the outermost level, in our case for back here, 3, tells us whether or not it will allow electricity to flow. And what we talk about this is we're going to start talking about the idea of conductors, semiconductors, and insulators. Those things that you guys have talked about for a long time, even from when you were little. Things that allow electricity to flow through it easily or things that don't. Okay? That's the key here. That's everything that we're leading to is conductors or insulators or sometimes semiconductors. So right here, the ability of an atom to draw electrons to itself or away from its neighbor is called electronegativity. All right, we're going to watch a video, and then we are going to do an explanation for what this looks like.
Electricity is all around us, and most of us use it every day. But do you really know what electricity is? To really understand electricity, you first have to start with an atom. Everything in the universe is made up of atoms. Let's look at this ant. We think of ants as being pretty small, but atoms are smaller, much, much smaller. Atoms are so small, in fact, that one ant is made up of too many atoms to count, more than 1 billion. If you take an object and keep breaking it down to smaller units, eventually you'll be left with only atoms, which we can call the building blocks of everything. Atoms have a couple of different parts, and a really important part of an atom is called an electron. Not all atoms have the same number of electrons. The number of electrons in an atom can change because electrons can move between atoms. Electricity is the movement, or flow of electrons from one atom to another. This flow of electrons is called current, electric current. Electrons can move in all materials, but they can move through some materials better than others. If electrons can move quickly and easily in a material, then that material is a conductor. A conductor is anything that allows electric current to flow from one point to another. The opposite of a conductor is an insulator. An insulator is a material that does not let electrons move well and doesn't conduct electricity. Have you ever seen the inside of a wire? The inside is usually made up of copper or another conductive metal, while the outside is made of plastic, an insulator. The copper wire helps the electrons flow, while the plastic insulator helps keep the electricity from being wasted and prevents us from being shocked. To use electric current to power things, you have to create a complete pathway for the electric current to follow. This is called an electric circuit. An electric circuit is like a racetrack of conductive materials that let the electrons flow in a specific way. For example, let's try to light a light bulb. First, you need a power source, like a battery. Next, you need to connect wires to the battery, and finally, the light bulb. Presto! Just like that, the circuit has been completed and the light bulb lights up. To learn more about electricity and circuits, explore the Curiosity Machine.
That's something we're going to be learning about later on this trimester, all right? So, So electron flow in conductors, okay? Take a second, and I want you to write this down, okay? So here is your, take notes. So how do electrons flow in conductors? Valence electrons get pushed out of the atom by valence electrons from other atoms. Basically what's happening is something that has a loose hold. You guys remember this is copper. There's one valence electron. Another copper electron is going to come in and it's going to smash into this and it's going to send it away. So basically it's kind of replacing. And if it does it repeatedly over and over and over again, when you get that constant movement, is how electricity happens. It's a switch. It's the instantaneous every time an atom bumps into each other. And, you know, when I say bump in, you think that it happens like bumps in, bumps in, bumps in. But it's happening hundreds of thousands, millions of times every second. And it's happening so fast. So what does that look like? Okay. So you should have took notes on here. And this is the last slide here, is the electron flow. So right here, we have copper atoms. And we are going to see an electron that comes in and moves from one atom to the other atom over and over and over again. Because right here, you can see, oh, that paused, one valence electron, one valence electron, one valence electron. Okay, so let's play the animation. Here comes the electron. It's moving, it smashes, and it goes through. Boom, boom, boom. Try it again. Oh. Comes through, smashes, smashes, smashes. And every time it smashes is when we see that electricity and we get it. So electron flow, it's created as electrons collide and transfer from atom to atom. So every time we're left off is when this moves, we are left with 0 electrons in the outer level, the valence level, which is what we want. Remember, either 0 or completely full. It has a loose hold, so this one can move, this one can move, this one can move. And this is allowing electricity to go through each atom, which in copper we know is a conductor, allows electricity to flow. So I want you guys to take notes, and I do want you to try to just draw these circles and show how one electron can kind of bounce back and forth. All right, take your notes. All right, I know this was a really long explanation, but this is super important for everything else we are going to do. Okay, so far we've covered how we get the number of protons, neutrons, electrons. We figured out what a valence level is. We figured out orbitals. Remember, the maximum number of electrons that can be in the outermost circle at the end when we're done putting in electrons can be 8, because there's 8 groups in our periodic table. Remember, the number of orbitals, which are the number of circles around the nucleus, can be maximum of 7. That's why there's 7 periods, the horizontal ones as we move down. Okay, so that's important because it tells us whether or not an element is a conductor, semiconductor, or an insulator. And we're going to learn about those maybe being called metal, non-metal, or metalloid here coming up in our next lesson. All right, guys, talk to you soon. Good luck.